I want to practice naming some alkanes, and I think the way that you should probably do this is take a look at the compounds I put up, stop the video, go through trying to name them, and then come back and see how I went through the process, because after I give you the compound, I'm going to go through the process of naming it. So let's start with this one. Why don't you go ahead, if you're going to, stop the recording and try to name it, and then you can see how I named it. Well, the first thing we need to do in naming this is to try to find the longest continuous chain. And it may be tempting to start over here and go 1, 2, 3, 4, 5, 6, 7, 8, or maybe here 1, 2, 3, 4, 5, 6, 7, 8. However, the way you want to do this is to start down here in number 1, 2, 3, 4, 5, 6, 7, 8, 9. And you'll notice I started down here because starting here, my first substituent is 3 carbons in. If I had started up here, my first substituent would have been 1, 2, 3, 4, 5 carbons in. So this is a 9-carbon alkane. Since it's 9 carbons, it's going to be a nonane. It's got 2 substituents on it, a methyl in the 3 position and a propyl in the 5 position. So the name of this compound is going to be 3-methyl 5-propyl nonane. Let's try this one next. Again, if you're going to try to do this yourself, you might want to stop it now and try to figure it out and then listen to what I have to say about naming this. Again, when we name this, we want to start by finding the longest continuous chain. And in this case, it's going to be 1, 2, 3, 4, 5. In this case, it doesn't matter if I call this my longest chain or this my longest chain. These 2 carbons and these 2 carbons are equivalent to one another. They're identical. They're bonded to the same carbon. If I got rotation around this single bond, this bottom group would flip up, this top one would flip down, and I'd have the same thing. So whether I start here, whether I finish here or here, I get the same numbering. I start numbering from this end because my first substituent coming this way is 1, 2 carbons away. Coming the other way, my first substituent would have been 1, 2, 3 carbons away. Since it's 5 carbons long, it's going to be a pentane. Off of that pentane, I've got 2 methyl groups, both from the same carbon, and then I have an ethyl group. So when I name this compound, it is 3-ethyl 2,2-dimethylpentane. Notice that even though both methyl groups are on the same carbon, I need a number for both of them. So one of the methyls is on the 2 carbon. The other methyl is also on the 2 carbon, so I've got 2 2s there. Okay, the last compound I want to look at naming is this one right here. So why don't you go ahead and give it a shot and see what name you come up with. The first thing we want to notice is that this group right here, 1, 2, 3, 4 carbons long, and this group right here is also 1, 2, 3, 4 carbons long. And they're both attached to the same carbon, so this group and this group are identical. So it doesn't matter whether I start numbering from here or here. I'm going to get the same name either way. So just to keep things simple, I started numbering from this one. Actually, if I clarify things a little, I didn't start numbering from that one. I started numbering from the other end because that gives me my first substituent on the 4th carbon rather than on the 1, 2, 3, 4, 5th carbon. But I included this as part of my main chain. So since there's 10 carbons, it's a decane. I have coming off of my decane, I've got 3 different substituents. 2 of them are methyls. One of them is a 1, 2, 3, 4 carbon butyl group. So when I go and name this, just going to see that we get 6-butyl 4,6-dimethyl decane. I put the butyl group first in terms of listing it because B comes before M alphabetically, so 6-butyl 4,6-dimethyl decane.